So at this point, we've spent a couple of days looking at graphing rational functions. Okay, the first day, we talked about how you can graph a function where you have just a number in the top with just x in the bottom, maybe with some transformations in there, vertical or horizontal shifts, but generally number in the top, x in the bottom. Okay, day two, we looked at functions where you had something like this, right? Where you had just an x in the top and the bottom, maybe with some other numbers multiplied or added, but power of 1 on both of these x's. So what we're going to look at today is how do you deal with it when you have an x squared or an x to the third, or if this one's an x to the fourth and this one's an x to the fifth. What do you do with that? Okay. This is where things start to get a little bit complicated, okay? And we're going to kind of fall back on using our calculator to help us. So what you're going to need to be able to do today is I'm going to ask you to be able to find your asymptotes from an equation and your intercepts from an equation, okay? And if you can find those things from there, you can graph on your calculator, okay? So let's take a look at these. So a bunch of words here. You can kind of go back and read this. I'm not going to read it to you. But the big thing I need you to take away from here is that when we set up these two functions that we're dividing, okay, I want you to notice that m is the degree of the numerator and n is the degree of the denominator. Okay, so that's going to be important. Okay, so let's talk about how we're going to find these things. Our vertical asymptotes, this is the same as it was with the level 2 ones. Set your denominator equal to 0 and solve for x, okay? And you're going to have a vertical asymptote wherever that is. Okay, quick reminder about the common factor thing that we talked about in the last class. So if that happens, it wouldn't be an asymptote, it would be a hole. Okay, so that's thing number one. So let's jump down really quick to the end here. Okay, this has got a vertical asymptote. So we want to take a look at this and just figure out, okay, I'm going to set the denominator equal to 0. So I'm taking this x squared minus 9, setting it equal to 0, and solving. So that's going to be positive or negative 3. So this one's actually going to have two asymptotes, x equals 3, x equals negative 3, excuse me. Both vertical asymptotes. All right, so that's step one. That's pretty easy. Now, step two, this is the one that's a little bit tricky because you are going to compare, remember we said m and n were the degrees of those polynomials? You're going to compare those degrees. If m is greater than n, so if there's a higher degree in the top than the bottom, if that's the case, then your asymptote's just at 0. Okay? If they're the same, then it's this ratio of whatever your coefficients are. Okay, so this is a sub m over c sub m. Those are your coefficients. The leading coefficients, if you will. Okay, so that's just, again, it's just like what we did in the method 1 of our second complexity. It's just the ratio of those two coefficients. If m is greater than m, so if the degree in the top is bigger than the degree in the bottom, then there is no horizontal asymptote. Okay, so this is a little bit tricky because you just got to remember these cases. So in this case, the degree on the bottom is bigger. So if the degree on the bottom is bigger, so if the top one is smaller than the bottom one, then it's just at y equals 0. So in this case, my asymptote, y equals 0. Okay, great. All right, and then our x-intercepts and our y-intercepts, you are just going to find those in the normal way, right? If you want your y-intercept always has an x-coordinate of 0. So I'm just going to plug 0 into this equation and simplify it. So these guys would both just go away, and I'd be left with negative 6 over 9, which it simplifies to 2/3, right? Okay, and then for an x-intercept, that always has a y-coordinate of 0. So if y equals 0, okay, remember how we solved these the other day, right? So if y equals 0, right, you'd multiply both sides by the x squared minus 9. So it would cancel over here, and this would just multiply to 0. And then this is a little baby equation to solve. Add 6, divide by 3, we're going to get 2. So that would be the point 2, 0. Okay, so from there, we're going to go ahead and put on everything that we know here. So my vertical asymptotes are at 3 and at -3. Horizontal asymptote at 0. Okay, and then Y-intercept is at 0, 2/3, so that's about there. And this one's at 2, 0, which is about there. And that is as much as we can do kind of just on our own. All right, now one thing that I want to talk about, you may be looking at this and saying, but Miss King, that point is on an asymptote. I thought that the graphs never crossed the asymptotes. That is true, but technically the definition of an asymptote, and we didn't get into this technicality before, but technically what the definition of an asymptote is it's just talking about usually end behavior. Okay, so it's looking at as your graph goes off to infinity, what happens. So a lot of times these graphs will cross your asymptotes somewhere in the middle, but as you approach infinity on either end, either the X or the Y's, right, that's where it's not going to cross the asymptote, or it will approach the asymptote. Okay. All right, so let's take a look at what this guy's going to look like. So I'm going to go to my calculator, go to y equals, put parentheses around the numerator and parentheses around the denominator. And I'm going to graph this. This is just a regular standard viewing window. Depending on what your operating system on your calculator is, you might see the asymptotes drawn in as big solid black lines there. Some of the software does, some of the software doesn't. This particular one does not. Okay, but you can see that's where the asymptote would be because that's where you have it splitting off in different directions. Okay, so all that I'm going to do is I'm going to kind of use my best estimation with this graph to kind of copy it over here. Okay, and we're going to use our table, which is not something we've done a lot of. But if you hit second and then the graph button, it's going to bring you to a table of values. Okay, and this is going to help you out a little bit as you go to plot some points. So what I kind of look at, you can see an error there where our asymptote was at 3. What I kind of look for is I look for any whole numbers or anytime you move between two whole numbers. Okay, so like 2, 0, 0's got a whole number there, so I'd use that one. And then I'm just kind of looking at these guys and I'm saying, oh, okay, well at -1, it was up above 1. So I'm going to add -1 just above 1, right? And then at -2, it was just above about 2.5, right? And then there's that error. So that kind of gives me an idea that, oh, look, this graph is going like this here. Okay. And then if I keep going past my asymptote at -4 was at about a little more than -2, right? So here's -4, a little bit more than -2. At -5, it was a little bit more than -1. Okay. Before that, it was just here. Okay. And that is enough to kind of give me an idea of my asymptote, or I'm sorry, not my asymptotes, where that section of the graph is. All right, let's go back over here. So there's that 2, 0, and then our error, but we know that this is going to be an asymptote, right? We know from looking at the graph that it goes like that. Okay, and then over here, I'm looking at this and saying, well, at 3, we had our error, but at 4, it was just under 1, and then it just keeps getting smaller from there, right? So that's kind of approaching down to our asymptote, and we're just sort of drawing it in. Okay, so you can see that it sort of matches here, and it just gives you an idea of what's going on in this graph. All right, so let's go through this again with another one. So vertical asymptote, set the denominator equal to 0 and solve. So x squared plus 1 equals 0. Well, when I solve this, I'm going to get something imaginary, right? What that tells you is that there is no vertical asymptote. Okay, so if you solve this and you get something imaginary, that's your cue that there is no asymptote there. All right, if I set y equal to 0 and solve, this guy is going to go away. So I'll have 0 equals x plus 8. Right, so x is going to be -8. Oh, I'm sorry. I just realized I messed that up. Man, I'm not doing well. Not doing well with the mess ups today. Horizontal asymptote. This is where we got to go to our cases. Okay, so with this guy, the degree on the top is smaller than the degree on the bottom, that's case 1. So my asymptote is just going to be at y equals 0. Oops, I messed that up. What I was thinking the y-intercept, right? I plugged in 0 for x, and when you plug in, 0 for y. Hang on. Let me pause for a second. Okay. For the y-intercepts always have an x coordinate of 0. So I'm going to plug in 0 for x. These are going to go away, and I'm left with just 8. For the x-intercept, I'm going to plug in 0 for y. And when I do that, that's where I got that -8 from before, right? If this is 0, multiply both sides by this, it stays 0. So x would be -8. Yeesh, okay, that was a lot of mess ups. Horizontal asymptote. All right, 0, 8 would be up here. -8, 0 would be out here. Again, it's on that asymptote, but that's okay. That's going to happen sometimes. All right, and now I'm going to throw this into my calculator. So I'm going to have x plus 8 divided by x squared plus 1. Take a look at what this graph looks like. Okay, so it's got this weird sort of pointy shape going on. I'm going to take a look at my table. Come back to where 0 is. All right, so 0, 8, 1 should be at 4.5. So that's about here. 2 is at 2, right? 3 is just above 1, and after that, we're down below 1. So that kind of gives you what this side looks like. And then over here, at -1, I'm at 3.5, which is interesting because this graph isn't symmetrical, right? It looked like it was going to be symmetrical when we first graphed it, but it's actually not. At -2, I'm just above 1, and after that, I'll be below 1, right? So here's where that comes to. Okay, and remember, there's not an asymptote there. These guys actually meet each other at that point. And that's what my graph looks like. Okay, next page. Okay, so another example here. So let's go through this one. All right, so first off, to find my vertical asymptote, set the denominator equal to 0 and solve. So x squared equals 4, x is positive or -2. So x equals 2, x equals -2. Horizontal asymptote, which I'm not going to mess up this time. In this case, the degrees are the same. So if the degrees are the same, your asymptote is just your ratio of your leading coefficients. Okay, so in this case, it would be 2 over 1. So it's going to be y equals 2. All right, y-intercept. The y-intercept always has it's a y-intercept, so it always has an x coordinate of 0. Plug in 0 here, these go away. 8 divided by -4 is -2. Okay. And then my x-intercept always has the y coordinate of 0. So I plug that in, multiply both sides by the x squared minus 4. I'm going to get 0 equals that stuff. Subtract 8 divided by 2. All right, this is too much for me to hold in my head. So I'm going to end up with basically 0 equals 2x squared plus 8. So -8 equals 2x squared. X squared equals -4. And this is where I'm going to get a positive or negative imaginary number, right? It's going to be a positive or negative 2i. So what that tells me is that there is no x-intercept. All right, let's take a look at what it looks like. Here's my 2 vertical asymptotes. Horizontal asymptote at 2. Okay, I know we're going through the point 0, -2, so that's down here. But somehow it doesn't cross the x-axis. That's interesting. All right, let's take a look at it. So 2x squared plus 8 divided by x squared minus 4. Yeah, interesting. Okay. Going to use my table to help me out a little bit. So let's see. In this kind of middle section at -1, it's at about -3.33. So that's about here-ish. Okay, and at +1, it's in the same spot. So this side does look like it's symmetrical. So there's that chunk. All right, and if I continue over in the negatives over here, so let's see, at -2, I've got my error. At -3, I'd be at 5 point something. So that's about 1, 2, 3, 4, 5, about there-ish, right? At -4, I'm at about 3.33. Right, then I'm at about, so I'm going to kind of jump just a little bit. At -5, I'm just below 2, or just below 3, right? And then from there, that's where I'm approaching my asymptote. So that's it. Okay, and then over on this side, so I'm going, again, I'm just kind of skimming down to where those errors are. And we're going to notice that it's pretty symmetrical, right? So I can sort of mirror those points over, and there's my graph. Okay, so we're using our calculator to help us out here. All right, so now I've just got a couple of notes for you. So first of all, note number 1, this is something that's going to come up when you get to pre-calc, but we're not really going to deal with this year. There's something called a slant asymptote. Okay, so a slant asymptote is exactly what it sounds like. It's an asymptote that's slanty. Okay, so that is a thing that happens, and it happens when the degree of these two, that this one is 1 less than that one. So when m minus n is just 1. Okay, that's when you're going to end up with a slant asymptote. Okay, so just as a side note, that's a thing. They exist. We're not going to deal with them this year. If you go to pre-calc next year, that's something you'll probably deal with. Okay, and then thing number 2 is just this note that we talked about with the asymptote. Okay, functions can pass through asymptotes. They don't pass through them as you get infinitely large or small. So you can see, like in this example, it does cross this asymptote. Okay, but what'll then end up happening is this will come up approaching again as it kind of comes through there. Okay, so it's as you go to infinity, that's where your asymptotes come into play. It's not necessarily always a hard and fast rule.